Welcome to the Analog Communication Engineering playlist. Here in this session, I will be going to explain the AM demodulation using Square-law demodulator. Therefore, in this session, I will be explaining you basically the AM detection technique by using Square-law detector circuit. Now the question is, what is detection? It is basically a process to extract the original message signal, or you can say the original information from the transmitted AM signal. Now what is AM signal and how we can generate AM signal, that we have already seen, right? So basically in this session we will see DSB-FC demodulation, because DSB-FC modulation we have already seen using Square-law demodulator. So basically this is the Square-law demodulator that I have already discussed in my previous session. You all know that using this Square-law modulator circuit we generate AM signal and we transmit that AM signal. Now the second thing is, from the transmitted message we need to get back our original information, or you can say original message signal. Okay, so that's why we use the Square-law detector circuit or Square-law demodulator circuit. Now here we can see the basic block diagram of a Square-law demodulator circuit. So here the input signal is not my message signal. Remember, that is the main thing. Here my input signal is the transmitted signal, and what we transmit, that is actually amplitude modulated AM wave, right? So here my input signal is already a AM signal. So we give that AM signal to a Square-law device where we basically use the Square-law principle that we have already seen in Square-law modulator circuit, and the output of the Square-law device will give to the low pass filter LPF, and from the output of the low pass filter we will get back our original message signal or original information. Now this is the actual circuit diagram of Square-law modulator that you need to draw in your university exam. So here we AM wave Square-law device. We can assume it is diode here, and from the output of the Square-law demodulator, the output signal is V2T. The input signal AMO we consider here V1T, and a low pass filter. From the low pass filter, we will get the output signal that will be definitely our message signal, that is considered as a V out T. So let's check from the mathematical derivation point of view the whether we will get, using this circuit, whether we will get our original information or message signal get back or not. Okay, so we know the input signal is a AM wave, so we know the standard AM wave equation I have already discussed in my previous session. Let's go through this lecture. So here it is, we consider AC 1 plus Ka mt cos 2 pi fct. We already know. Now the non-linear characteristics, mathematically we can express this in this manner. Already I have discussed in the Square-law modulator circuit. So we all know that it is V2T is equal to K1 V1T, K2 V1T square plus K3 V1T cube, and those are the higher harmonics. We will consider only the square terms. Okay. Now here V1 is the input of the Square-law device, which is nothing but the AM wave. This is AC into 1 plus Ka mt cos 2 pi fct. You already know. V2T is the output of Square-law device. Already I have shown it in this figure, the circuit diagram, and K1 and K2 are nothing but constant. Okay. So this is the mathematical derivation. This is very simple. Just go through it. Now V2T will be, so K1 into V1. V1 is my AM signal. So AC into 1 plus K mt cos 2 pi fct, and K2 into the same AM signal square. So if we break it and if we simplify it, we will get our this much of different frequency terms. Okay. So we have marked here, right? These are the green terms, some are the red square, and one is the blue terms. Okay. Now here this we use a LPF, right? A low pass filter. Now what is the purpose of low pass filter? You need to first understand it. Low pass filter is a kind of filter where actually a we set a cutoff frequency of the low pass filter. Here our desired frequency is our message signal. Now what is the frequency of a message signal? That is we consider here FM. So suppose we fixed our cutoff frequency here at FM or the message frequency of the message signal MT. Okay. So that means low pass filter will pass all the frequency components that is below the message signal frequency of MT, and above that any frequency component it will be mitigated. Okay, so let's consider the first one, K1 AC cos 2 pi FCT. Here the frequency component is FC. Now FC is greater than FM, so it will block. So first frequency component is blocked. Okay, now second frequency component is MT cos 2 pi FCT. So we all know that if message signal is multiplied with carrier signal, it will generate LSB and USB term, that is FC plus FM and FC minus FM. Both will be very much greater than to our message signal frequency FM. So this frequency is also blocked. Okay. Now next come to the this red box, that is K2 AC square by 2. Now this is a complete DC signal. So here we use in the circuit capacitor. So this capacitor will block this DC signal. Okay. Now come to the next term, that is K2 AC square by 2 cos 4 pi FCT. So it is the main, the frequency component is here, it is FC. So FC is greater than our message signal frequency MT. So it will block. So this term will also block, right? Now the next term, K2 AC square K square MT square 2. Now it is the square of message signal. So it will, we all know that it will block, right? Now come to the next term. It is again the square of message signal, and also it is multiplied with cos 4 pi FCT. So definitely this frequency, the frequency components, after simplify this signal, it will much more greater than compared to the FM. So this signal will block. Now come to the next one, that is K2 AC square K MT. So this is my message signal MT. Here the frequency component only exists with my message signal MT. So this will only pass. Okay. So only this signal is plus, that is the blue box. Okay. This signal is pass. Now come to the next signal. It is again K2 AC square K MT cos 4 pi FCT. So it is again, we know that it is it will become to the FC plus FM and FC minus FM 4. So it will again block. So among these 1, 2, 3, 4, 5, 6, 7, 8 frequency component, only the K2 AC square K MT frequency component will plus, and remaining all the frequency components is greater than compared to the cutoff frequency of my low pass filter, that is say tuned to my message signal. So all these frequency components will be mitigated. So only one frequency component will pass through my low pass filter, that is K2 AC square K MT, which is nothing but my message signal with some amplitude constant. So definitely we will get back our original message signal using the Square-law Demodulator circuit. Here I write it, you can go through it, that in the final expression V to T, the term encircled in blue, that is K2 AC square K MT, this, or what I already explained, has to be retained, and other have to be eliminated. The terms encircled with green can be eliminated by the low pass filter. These green terms already I have discussed, and these red terms are eliminated by the capacitor because it contains the DC terms. The constant terms will be eliminated by the capacitor, which is a red. So only the one frequency component is passed, that is the scaled version of my message signal. So in this manner we will get our original message signal, or you can say we will get back our original information from the transmitted AM signal. So this is all about AM detection by Square-law Demodulator circuit. Thank you so much for watching this video. You can give me your valuable suggestion and queries regarding what is required here in this analog communication engineering course. Definitely I will get back to you based on your queries. And in future we will be finding many more subjects regarding engineering. So stay with this channel. Keep motivating your friends. Thank you again for watching this video. May God watch over you. Thank you.